Hello students, welcome back to ITC class. Started the fifth module, the last class. See, now we will see the difference between the block codes and the convolution codes. What are the difference? Look at in the first block code. Coding is a block by block, but in convolution it will be a bit by bit. And for a block of message, bits encoded block of code vectors are generated, and here instead of the block it will be generated, bits are generated in a convolution codes. Block codes are represented by n comma k notation, and convolution codes are represented by nkm. Generator matrices, parity check matrices and syndrome vectors are used for analysis, and here code tree, code trellis and state diagrams are used. Generator polynomials are used to get the code vectors. Here generator sequences are used to get the code vectors. Output of block codes depends on the present inputs, but in the convolution code we defined present as well as the previous inputs. Block codes, it will be always larger or greater than n comma k, and here in the convolution code it must be a k is less than n, k must be a less than n. Then the distance properties of the code can be studied from the code vector, and here it is studied by the transfer function. Error correction and detection capability depends upon the minimum distance, that is d minimum, and here that the error correction and detection depends upon the free distance, that is a d free. For decoding, syndrome calculation circuit is used. Here for decoding, Viterbi algorithm is we are using. We will see what is the Viterbi algorithm here, that our one more algorithm is there. Block codes are generated by message block and the generator matrix. So here convolution codes are generated by the message sequence and the generator sequence. Look at the examples as I given. In block code it is c is equal to d into z, and here in this c of x is equal to d of x into g of x. Okay. Now the representation of convolution codes, there are three methods. Just now we have discussed in the difference. Convolution codes can be represented using one of the following three methods. Three methods are there to represent the convolution method. First one is state diagram, second is tree diagrams, third is trellis diagram. So this example I have considered same example what I solved the previous. By considering the first example 2 1 2 diagram, it is 2 flip flop ff1 ff2 top adder bottom adder and 2 outputs. By considering this diagram, we are going to define and study the state, tree and trellis diagram. Let's look at the first one, state diagram. So what is the definition of this is, which is a very easiest method of representing the convolution encoder compared to the trellis and the tree diagram it is, but it cannot decide the present state of the system at a given instant of time. Means it is not able to decide the present state for a given period of time. How to construct this state diagram? There are some steps, or the method is there. First you have to find out the state table. State table. So how to find out? Look at in the diagram, above diagram, how many flip flops are there? 2 flip flops in the shift register. Therefore how many states? 2 to the power of 2 is equal to 4 states with the binary data. So thus let the states be a, B, C and D represented in the table. So how many states? You have to make it in the table. One side state, another one side binary description. So A is B, C, D are the states. A is equal to 0, 0. I am assuming that state is a 0 because only the 4 combinations are there. B is equal to 1, 0. C is equal to 0, 1. D is equal to 1, 1. So this is the combination. First step. Second step is state transition table. So what it is indicating here in the state transition table is it is between the state, means the transition between the states and also corresponding code bits output during the each transition. So, look at here. Now, writing the state transition table. Input, it may be a 0 or the 1, two combinations I have taken, 0 1 0 1 0 1 0 1. You may ask how it is, because we do not know that it may be a, for 0 combination the state may be a 0 0, for 1 combination the state may be a 0 0. So, 2 times I have taken 0 0 0 0 1 0 1 0 0 1 0 1 1 1 1 1. So, it is A B C D state. Next state. So, next state will be a input plus first bit of the present state, 0 0 1 0 0 1 1 1 0 0, like that you can consider here. Output, you have to see the result here when it shifts. So, the output will be a, based on that it will be considered. So, this is second step. Third step, state diagram. Once you got this, after getting this transition table, you have to put a 4 state in a state diagram. So, A, B, C, D, 4 states we have considered. Look at the transition now. A to A, A to A, it is 0, correct no? A to A transition is 0. So, I am using the thick line for the input 0. For 0 input, A to A, thick line. A to B, it is 1, A to B, okay. So, thick line it is by 0 input and dotted line by the 1 input. So, look at the output here. For A to B, input is 1, that is a dotted line. Look at the direction, I am showing the direction arrow marks towards the B, and output is 1, 1 1 I represented on that. Next, second one, B to C. B to C is input is 0, as it is shown by the thick line, and output is 1 0, it is shown here. Like that, you have to complete the whole task. This is the representation of state diagram. Like that, B to D is there, C to A, C to B is there. Look at the last combination, D to C. D to C, input is what? 0, thick line, output is a 0 1. So, this is the state diagram. Now, the tree diagram. In the tree diagram, you have to split the whole, that is upward and the downward. Upward I have taken the 0 to start, downward it is a 1. So, 0 0 1 1. Go on, split into the, as you drawn the tree diagram, in the same way you have to split into the 2 ways and label on that the outputs, that is 0 0 1 1, A and the B. Again A B you have to divide. Finally, it is A B C D at one side and A B C D at the one side, means upper part is the 0 part and the below part is the 1 part. So, these are the representation of tree diagram. Trellis diagram, you have to take the 4 states I have taken, 4 states left side, 4 states right side. Depending upon that, look at the outputs, you have to connect it A to A to B. So, here again you can look at here, thick line I am using A to A, it means input is 0, output is also the 0 0. When I am using A to B, I have shown with the dotted lines, output on that it is a 1 1, means dotted means when the input is 1 it is. So, A B C D at the left side and A B C D at right side, when you draw with the diagram. So, this diagram is called as the trellis diagram here. A to B, then B to C, B to D, C to A, C to B connectivity, D to C, D to D. Okay. So, next class we will see the Viterbi algorithm. Thank you, students.